Welcome back to another episode of Precision Perspectives. Today we have Brook Sandy, the RF and microwave applications engineer at Knowles Precision Devices. Brooke, I'm super excited to have you on today. Say hello to everybody.
Hello, thanks for having me, Jordan. I'm excited to be here.
Of course, I'm excited you're here as well. Also, I think I forgot to introduce myself. Guys, I'm your host, Jordan Yates, marketing engineer at Knowles Precision Devices. Today, we're going to kind of get into the RF and microwave filter world and take a very specific look at a component that is called a microstrip filter. Now, even though I work at Knowles with Brooke, I know nothing about microstrip filters. So I'm just as excited as you guys are to learn a little bit from her and get a good grasp of it. Brooke, is your enthusiasm as high as mine right now?
Oh, absolutely.
It's through the roof.
Always for these products.
Microstrip is life. No. So I'm just going to put us right into our first segment, which is called Say It Plainly. Now, I want us to be able to understand what a microstrip filter is. So, for anyone who is new to RF and microwave components, can you explain to us in simple terms, like what it is and how it falls under the RF umbrella?
Absolutely. Well, a microstrip filter uses microstrip technology. So basically, on a ceramic substrate, there are thin films of metal that carry the signal. So these are used for RF signals. And a filter pretty much does what it sounds like it does. It takes in all of the RF and microwave signals coming in and filters out so you only get the ones that you want through. So we use terms like low pass, high pass, band pass for these, and those pertain to what frequencies of signal the filter is going to let through.
Mm-hmm.
And then also band stop would be the opposite, where it's blocking out a band of frequencies so that those don't come into your device.
That sounds cool. And if I were to look at the product in person, could you give us sort of an idea how big is it? Like is it, a big component? Is it something really tiny? Like can you give us sort of a grasp of what that looks like?
Well, you're used to working with SLCs, so these are going to seem big to you. But compared to other technologies that do this kind of filtering, these filters are pretty small. I would
Mm-hmm.
say generally less than an inch.
Oh wow.
And I have shared a picture with you where you can see some of our smaller filters that are much smaller than a quarter. So, and those already have the integrated shielding.
Mm-hmm.
So we're able to add a cover to protect the performance of the part and block out other potential sources of RF and microwave radiation.
Sounds fancy. I like it.
Yes.
If you guys are watching on YouTube, we'll pop the picture up that she's talking about. Brooke is actually the first guest to provide me with materials like this. So this will be a special episode of you guys getting to see some visuals along with learning, through audio. Yeah, Brooke. Now, I'm aware that DLI, Dielectric Laboratories, a company that Knowles has acquired, is really specifically specialized at creating these microstrip filters. Can you kind of tell us why they're so good at it?
Well, our filter technology is a little bit special because DLI makes our own ceramics. So, on other filters on the market might be built on alumina, that would be pretty common, but Knowles makes our own ceramics, which gives us more capability to miniaturize these filters. So it makes it so that we can get the same performance or better performance in a smaller footprint. But also, um, we've worked hard to make these ceramics more stable as you go over a wide temperature range so that your
Mm-hmm.
performance stays the same. Whereas with alumina, that's kind of one of the downsides that you can have the frequency shift that you'll see going from a low temperature to a high temperature.
Gotcha. And Knowles doesn't do any of the alumina at all. It's just the
No,
ceramics
we
more
also
so.
do alumina.
Oh, so we just do
We don't
everything.
make, we have our own version of alumina that we call PG.
Okay.
So that has some more temperature stability, but we also make lots of parts on alumina. That's just, the highest quality on the market alumina.
Yeah, no, that's cool. And it's very interesting to make your own ceramic. I feel like that takes a special level of knowledge to be in like the material science. And you said you have a chemical engineering background, so I can imagine that's pretty interesting for you.
Oh yeah, for sure. I'm always a materials girl. And one of the cool things about making our own ceramics too was that we had a really stable supply. In the last couple of years when there were chip shortages and stuff,
Hmm.
we never had an interruption in supply because, we bring in all of our raw materials and make our ceramics.
Wow. It's nice when you can weather the ups and downs of supply chain. Like I feel like we really learned that more than ever during the pandemic. So
Hmm.
it is cool to have such a niche technology that we're capable of keeping up with. Um, Now I want
Absolutely.
to Oh, sorry, what were you saying?
Absolutely, yeah. I mean,
Yes.
the other side of the precision manufacturing is the photolithography and the way that we create these thin film microstrip filters.
Yeah, I've seen only a couple of our facilities. I've gone up to the KCC one that does more the microwave stuff, and then I've gone to the one in California that does capacitors. And it is a very interesting process seeing them be made because I'm not used to watching such tiny little things be produced. Like it is very interesting. It must be cool for you to actually know deep down like what all of that process entails and then why it's like that.
Oh yeah, yeah, definitely. Some of these, like photolithography, is a common process for lots of different electronics manufacturing, but to see it applied in this way and to have components that are on a ceramic substrate, that was kind of new to me. Coming from the electronics world, and then when I came to Knowles Precision Devices, that was the coolest new thing, was that everything was built on ceramics.
Yeah, no, that's definitely an interesting point of ours of the ceramics. That's what I learned right away, and then as I got to know the other products that we offer, I'm like, is everything ceramic? What's ceramic? What's not? And then I get confused when something isn't ceramic. I'm like, I thought ceramic was everything. So it's definitely interesting to get to talk to other people in the company like you, where I can learn a little bit more personally, as well as have our listeners learn too. Now,
Yeah.
when we're talking about listeners, that puts us into our next segment, which I call Who Should Care? So I want to know who you think should be interested in better understanding these DLI microstrip filters and how they're relevant to various audiences, whether it's, somebody that's in college or somebody that's been doing this for so many years, they know what it is, but like who would want to learn more about this?
Yeah, I think typically I'm talking to RF engineers, RF designers most of the time,
Mm-hmm.
because these parts really go into very specific applications. But people that have been around for a while might not be so familiar with this technology.
Mm-hmm.
We keep developing new topologies and new ways to achieve different performance in the filters, better performance. So, someone that's been around for a while might find something new with us, and someone that's new to this field might find some of our information that we have on our website interesting. And
Mm-hmm.
I would like to think that we're very, very easy to work with. Our engineering team is here to help, and whether you need to talk to an RF designer to work with them to decide on something that's perfect for you, or you want to talk to me and I can help you use the parts once you get them. We have an email address called dliengineering at knowles.com, where you can very easily reach out and get to talking to someone on a technical level pretty quickly. So I think that's one of the other cool benefits of using these products.
I'm gonna email you guys when we're done.
We'll be waiting.
Attention, Brooke. I just wanted to say hi.
Here's a list of questions.
Yes. Okay, so now I'm curious in the real world. When it comes to real world applications, like you mentioned, these are filtering out signals, they could stop RF signals, and we kind of know what it does, but like where is it being used? Like, who wants to filter out signals? I feel like to some people that are newer in this industry, signals seem like a very vague thing, but can you kind of explain like what filtering a signal may look like?
Well, I think the most common industries that I think of for this might be fighter jets, or
Hmm.
we do some stuff for 5G. So satellite communications, anywhere that you're trying to send data or transmit this kind of signal. So um, I think. um, more than just the applications that it's in. The important thing is how we use these parts.
Mm-hmm.
So it's sometimes filtering like this could be integrated into your printed circuit board technology, but these are integrated parts, like I said, with shielding integrated, so they have a shield already.
Mm-hmm.
And so these, quite often, we're selling for surface mount, so to be soldered directly onto the board with other components, with to do the whole assembly together. So that's kind of unique to these parts.
Mm-hmm.
And one of the really cool things that we can do, since we can make things so small, we can also integrate together not just a filter, but a filter and a power divider, or a filter and a gain equalizer onto one part, or we could terminate a port or something. We can integrate together different functions from RF technology onto one part, so you can do one placement or one assembly and
Mm-hmm.
get these multiple functions in the performance.
Is it typically that like a customer reaches out to you and asks, can you put this stuff together? Or is it they ask for something and you're like, listen, I have a really cool way of doing this. And you're the one who presents, it's like, hey, we can actually kind of lump this all together.
I mean, both ways. So on our website, we have a whole list of different parts, at different frequencies and different performance ranges,
Mm-hmm.
different approaches that kind of show the selection, or like how well our technology can perform. But
Mm-hmm.
then also, we do a ton of custom designs. So if a customer has a spec, we can either say, "Oh yeah, we'll just do that," or if it's something complicated that we have that's new, we haven't seen before, we talk through it, and our design engineers come together and provide solutions.
How long did it take you after working at Knowles to know, like, when somebody asks you for something, if it's something you could actually do? Like, was there so much variation in our capabilities that it took a while to catch on of like, oh, we can do this crazy thing or we can't? Like, how was that learning curve for you?
I haven't seen very many things that have come through that we can't do. Usually we we if someone in the industry needs it, we'll push forward when we have some different strategies to try and deliver. So, um to be honest, I haven't seen many times when someone comes to us with something different. I mean, also, I'm talking about DLI today, but we acquired the RF filters, like you were saying, from California.
Mm-hmm.
So with these other technologies that Knowles Precision Devices is adding to the portfolio, we have a couple different ways now to give you a similar thing. And that really helps us meet the customer's demands, kind of whatever they are.
Yeah, no, that sounds pretty fun. Like usually I've had jobs before where I was like more in the sales side and you get customers that ask for a lot of things and the young salespeople always say, yes, yes, I can do that because they like want to people please. But
Hmm.
then you go back to like the engineers and they're like, why would you say yes to that? Like we cannot do that. That's not a real solution. You just made something up and now we have to go back and tell them. But it sounds like it's the opposite here. Like we just really can do all this crazy stuff and like we do put a lot of thought into the actual engineering and the development where our specialty is the crazy stuff and we make it happen. That's
Yeah,
pretty cool.
absolutely. That's exactly how I would say it too. It's a very customizable technology.
Yeah.
And I mean, if there are trade offs, say there's a spec that we can't meet, well then we could change the size to meet it, or there's some negotiation we can play with the designers.
Yeah.
It's
Is
fun.
that fun for you getting to like work hand in hand with like so many people you might not have crossed paths with otherwise?
Oh yeah, absolutely. All of this RF technology is really cool, and it was kind of a niche to the printed circuit board assembly industry. It was kind of one small sector dealing with these RF signals, and it feels very mysterious, but then you realize, oh, it's just waves at different frequencies with data in them. Which one do you want to listen to?
I still to this day like my brain doesn't fully grasp how those like waves are moving through the air, but I think my first time I had like a familiarity with like associating this to something real was my brother-in-law had this like the speed thing that you put in your car to see if like a cop is like coming by and it goes KA band and I'm like
Hmm.
didn't process what that was until years later I look at our website and I see like KA band and I'm like I get it. I understand
It's for
RF.
radar detection.
Yeah.
Well, that's, I guess, an interesting application. I haven't
Yeah.
run into that much, but yeah, I mean, when I think of examples, I usually go back to my first car and
Hmm.
having a radio in the car with the turning the knob to tune into the station, saying, I don't want to listen to, 92.6. I want 93.
Kids
And
these
so it's
days will
kind
never
of what
understand.
filters are doing. Yeah.
Like, what is a radio? I listen to
A
Spotify. Like,
radio. Yeah. Is that where you get your playlists?
yeah, literally. No, it's so fun. It's like crazy that all these things that used to be more, I guess, analog that you had these various inputs into do provide such a foundation to the stuff that we do today that I can only imagine being an engineer entering the workforce now that there is a little bit of a disparity of examples that you could give them to make them understand this. So it's nice to have a mix of ages within the industry so we can tell them what a radio is and how to tune it, you know?
Of course, yeah.
So, what about some high tech critical applications? You were telling me about some space related stuff that some of our products have been in that you find cool. Can you tell the listeners about it?
Oh yeah, absolutely. I mean, the first one I think of is how much space heritage Knowles has.
Mm-hmm.
With the DLI die caps going all the way back to the earlier days of the company. Um, I always think of the Mars rover as being one of the coolest things. I think there were filters on the Mars rover, as well as, Knowles provided the microphone that listened to the first sounds of Mars. So that's one of the coolest things I can think of. But there are also some secret things that we go into, or flight things that our parts go into. So um, we are really capable to handle those requirements, like flight requirements. You would have to make sure that every single part that you use is perfect. So we do a lot of extra testing on those parts, and we can accommodate those customers that maybe have secret hardware or secret frequency. We have secure manufacturing facilities where
Mm-hmm.
we can make those sort of really specialized secret parts.
That's cool. It's like it makes you just feel a little bit more important with the day-to-day stuff that you're doing. Of like, I'm literally like a secret FBI agent making capacitors, but not really, just sort of. Like,
Yeah. Well,
I
keeping
was,
our communications secret can be a pretty important thing for security. So, absolutely.
yeah, it really is, especially with all the electronic warfare that's going on these days. Like that stuff is just more important than ever. And then even just the like regular satellite signals. I just, before being at this company, I would think like the satellite, it just does it. Like I never thought like how it does it or how you send these signals. I just knew there's a big chunk of metal floating in the sky and it makes things know what they're doing. And like it's weird when you go from such a big picture view to like now we're in like the smallest little piece of the puzzle. So it's
Hmm.
it's definitely really cool to look into.
Definitely.
Now, what about trends? So, what are some things that you see are like a commonality amongst a lot of things within like the microstrip filter world, like requirements, or I know you said there's a lot of like specialty ones or like maybe defense related. What's like a trend that you see amongst them?
Yeah, I would say across all of the applications, there's this acronym called SWAP-C,
Mm-hmm.
which is minimizing the size, weight, and power requirements. So no matter which application you're talking about, they're all striving to minimize the size, weight, and power requirements for the parts that they use. Of course, these are passive devices, so they don't require any power, but we are really good with our ceramics at minimizing the size and really maximizing the performance of these parts. And then also, I think about the cost of ownership.
Mm-hmm.
So not just how much it costs to buy a part, but how much it costs to manufacture your assembly with that part, and avoiding rework and having high first pass yields to make sure that this part is the best solution for the whole, not just the buying part of it, but the whole life of the assembly that you're making. Um, so these parts, we 100% RF test all of the filters before they go out. So you know that you're getting a filter that meets the specs. that
Hmm.
that were set out, and we also try to provide a lot of support on how to use the parts. So our design files online include the printed circuit board footprint, so you can get the layout of the printed circuit board land good, and we have the microwave products guide that tells a lot of our best practices for, stencil design and do this, don't do this, and we really try to give as much information up front as possible so that your first time assembling these filters, you get really good results.
It's just so nice of us that we do all that.
Well, we put all the work into making a fancy filter. You should be able to assemble it and still get that performance instead of ruining it somehow.
Amen.
So,
So when people are looking for these like fancy filters, how often is it that when they see the price, like you said, we're not necessarily playing the price game of the initial like buying the piece. It's more about the total cost of ownership and all that. How often are people like shocked, like, oh, wait, this costs more than I thought I would? Or do you feel like a lot of people in the industry, they're kind of aware of the trade off of like, if you invest more now, it's going to be better later?
yeah, I think the performance difference is enough that even though there is a cost difference with this technology, that it's worth it because you can, for instance, we call getting rid of the frequencies that you don't want rejection. So
Hmm.
you might be able to achieve better rejection closer to your band with our filters than you would with some other filter technology. So that question is really about what you're comparing to. Can you achieve what you're trying to do with a cheaper technology that might be more complicated to use? Or will you get better results at the end of the day using this technology, but it also gets you, oh, you can use a smaller board or you can have more components closer to it, or, there are valuable trade offs there.
Yeah, absolutely. It's always interesting to see like when people bring up price because I feel like that's always a conversation, and that's the cool thing working at a company like this is we don't need to chase after every single deal. It's more like, looking at the high quality, more engineered applications. That kind of leads into my next question, which is sort of how is there the difference or like the deciding factor when people are choosing between like an off the shelf solution or they're like, you know what, I think I need something more customized. Like, where's usually the deciding point there?
I think it's all about the frequency ranges. So with our catalog products, I call them COTS,
Yeah.
off the shelf parts. Um, we targeted what we think are common industry frequency ranges, but you might be doing something that's a little bit different. Maybe you need a little bit narrower band, or maybe you need it to be 4.7 gigahertz instead of 5. But I mean, there's a wide range of solutions from, hundreds of megahertz frequency all the way up to more than 60 gigahertz. We're really only limited by how high frequency we can test. We can do, we can do, we could achieve filters that go even higher than 67 gigahertz, but we can't test them yet. So there's just such a wide variety that it's possible that you're just doing something in a frequency range that we haven't got an off the shelf solution for yet. And you'll
That
notice
makes
also
sense.
there are other microstrip devices available, like power dividers that can split a signal into two lines, or combine a signal from a couple different lines into one, or couplers and gain equalizers, these kind of adjacent parts that you would use with filters. We also can offer those.
I feel like I never truly conceptualized power divider until you just said that. That makes sense. What is
Yeah,
that
it's
makes
pretty
so much
easy. You
sense.
have one and then it splits into two equal ones, or you can take two signals that are similarly matched, and the divider would combine it.
It's weird like that sometimes you can read this in like a technical paper and like it just doesn't soak in, but for some reason when you say it out loud all of a sudden I'm like, aha, I get it. Like, no, I get it. So
It's my
thanks, Brooke.
superpower.
Yeah, clearly. No,
A
it's
simple one.
I it is a very important one, okay? Like
Mhm.
you're doing us a favor. We all appreciate it. I know the listeners will too.
Glad to
So
do it.
I want to transition to more of the lighthearted, fun side of the podcast. Not that, honestly, I mean, this has been pretty lighthearted and fun to me, but in case we've been too technical, we're going to make a pivot and do some fun and quick questions. This is our rapid fire round. So I was hoping you could share a fun or unexpected fact related to any of the DLI components, or maybe a quirky anecdote or something that's happened while you've been working in this field.
So, remember earlier this year when they were trying to roll out 5G, and you know how 5G has been delayed, delayed, delayed? One of the things that came up was that um, the towers at airports would get interference from the 5G technology because the frequency range is different than they were used to. Well, one of our filters was perfectly perfectly designed to fix that problem and fit into that application where we could help out the 5G world and try to get over that hump of interfering frequency ranges. So that's one kind of cool application that came up recently where it's a major hurdle for a technology being released, and we could contribute to a solution for that.
That's really cool. Like probably seeing that stuff in the news and like hearing about it. And then it's like a little hair flip moment of, yeah, like I helped solve that. The world, you're welcome.
You're welcome. You're welcome with your 5G technology.
Seriously. I mean, although I would say I feel like since the 5G is coming out, my phone always says it's on 5G and then I'm not getting like any data. And I don't know, that's probably on Verizon. No shade to Verizon or anything. I don't know. But I need some more filters, Brooke. Hook me
You're
up.
probably not using our filters, yeah.
Exactly. That's what I think. Anytime something that's electronic isn't working correctly, I'm like, there's no way Knowles is in this. No way, because this
No
would be
way.
perfect if they were.
Actually, the statistic about our microphones being, every one of us probably has 5 to 7 Knowles microphones in our house.
Oh my God, that's
It's a pretty
crazy.
crazy statistic, just how pervasive, all of those devices that have microphones are.
It's
If you have an Alexa and you have your Siri and all of the different assistants.
That's actually kind of crazy because like before working here, I had no idea who Knowles was or like what, like never heard of it. And then when you start working here and you realize it's literally all around you, it's pretty crazy.
Yeah. I am disappointed though that we don't get to work with Beyonce.
Don't count it out, Brooke.
I
Like
know. I know.
it's not over
She
yet.
doesn't
She's
own she doesn't own Knowles Corporation actually.
not, not yet. So
No.
Beyonce, if you're listening, we'd love to work with you sometime.
Yeah, we have some name synergy that we could work on.
Absolutely. Well, Brooke, we're just about getting to the end of our episode. This has been really fun. More fun than I thought I could have talking about microstrip filters. But before we sign off, I was curious, do you have anything else that you want to say to our listeners?
Just hop onto our website. Check out all of our selection of off the shelf parts that you can find there. And make sure, if you're going to pick up some of our parts, to find the microwave products guide. It's on our catalog page, along with the microwave products catalog. And that'll give you a lot of tips on how to use our parts once you get them and get really good results.
Love it. And I will put that email that she told us about in the episode description. So if you guys want to reach out to Brooke for solutions or just to say hi, because she's clearly pretty cool, then you do you, and I'll let Brooke take care of responding to those. But Brooke, thank you so much
Awesome.
for coming on again. Guys, that is all we have for today on our Precision Perspectives podcast. As always, I'm your host, Jordan Yates, and I will see you next week. Bye bye.